Like we were starting to learn in our last video, the stress response is adaptive. Our fight or flight response has evolved because we need to be able to survive. In order for our species to survive, we as individuals need that survival instinct. So the stress response helped our ancestors and it helps us as well. If they, came out of their cave and were, encountered a saber-toothed cat, they need to be able to have an appropriate response to that challenge or that threat. We, in certain situations in our lives, need stress because it is a motivator. It pushes us forward. Like we said, with the math test, right? In our last video that we talked about. When we properly appraise a stimulus and decide the best way to deal with it or to cope with it or to meet the challenge, that's something that's good for us. The problem is that this stress response that evolved, for our ancestors to be able to survive, it's a little bit different when it comes to the modern stressors that we face today. Those modern stressors aren't short and quick. We don't see the saber-toothed cat and then, successfully flee from it and it's gone until the next time we encounter it. The types of stressors we face today, like work and school and relationships, we are immersed in constantly. And this means that we experience more of what we call chronic stress. So, this automatic, very quick response that evolved for quick action in our ancestors can impede our survival and do the opposite of what it's supposed to do when it's prolonged. And that's what we're talking about today, the dangers of stress. General adaptation syndrome is the name we give to refer to the physical stress response. General adaptation syndrome because all stressors produce the same physiological response in our body. So regardless of if we're in a near car crash or we're facing lots of stress at work or at school, our body is going to adapt or respond in the same way. In the car crash scenario, it can lead us to quickly react, slam on the brakes, do what we need to do in order to, properly get out of that situation. But when we're talking about work and school and relationships, the stressors that don't go away, well, the body keeps having that same stress response. And over time, it can lead to heart disease, asthma, headaches, ulcers, arthritis. And this has to do with the secretion of particularly the hormone cortisol. So cortisol, when secreted in excess, first of all, it takes a lot more time in order for it to act, but it also lingers in the body and it can cause very adverse health effects. So when we talk about stress and our immune system, remember our immune system is our body's physical defense against disease. And you're going to learn a little bit more about this when you do the concept practice. So I'm going over it kind of briefly. But essentially, acute stressors like that near car accident or being chased by an angry dog can trigger your natural immunity. Even exercise would be an example of an acute stress or an acute stressor. It can trigger your natural immunity, which is a good thing. But it can turn on itself, the immune system can turn on itself, that is, when we're faced with chronic stressors. It can lead to immunosuppression. Those who experience chronic stress are more susceptible to illness. We'll look at research on that in a second. But let's talk about the three phases of general adaptation syndrome: alarm, resistance, and exhaustion. Let's start with the alarm phase. So at the first onset of a stressor, we have an alarm reaction. Our sympathetic nervous system kicks in, our heart rate increases, blood's diverted to our muscles, our digestion halts, and we feel, the faintness perhaps of being in shock. But our resources are now mobilized and we're ready to fight back. So in the alarm phase, our body is mobilizing its resources. Our fight or flight response is kicking in. Sympathetic nervous system is kicking in order to help us cope with a stressor. Great. Now in the resistance stage, the body is adapting to the presence of that stressor. It's restoring homeostasis. Our temperature, blood pressure, respiration remain high. Our adrenal glands are pumping hormones into our bloodstream. We are fully now engaged with the stressor. We're sitting down to that math test and we're doing it. All of our body's resources are rising to meet the challenge. Test is over. Awesome. We return to normal. Here's successful resistance. But what if we don't successfully resist the stressor? What if we do terribly on that test? Let's say we were over aroused and we couldn't focus, we couldn't concentrate, and now we've got that night's homework and the next night's homework and the next test and the next test and the next test. Well, now we're getting ourselves into what we call the exhaustion stage, which is we've been staying up late. We've been pushing ourselves so hard. We're mentally and we're just physically so drained from the stress of all the work that we have to do. Our body is depleting its resources. And in extreme circumstances, this means that we're more susceptible to illness. Our immune system is compromised. In very, very severe circumstances or very extreme circumstances, it can even lead to death. But we're talking about scenarios that are different from the test example that we're learning about or that I'm using. So there's some research that goes back to the 1980s on the effect that the stress of exams have on the immune system. So in this particular procedure from this particular study, blood samples were taken from 75 volunteer first-year medical students. The independent variable is that the blood samples were taken 1 month before final exams when students are experiencing relatively low stress, and then during exams where obviously stress is kicked into high gear. As a dependent variable, researchers are measuring the immune functioning by looking at their T cell activity. Your T cells are lymphocytes that fight off viruses. So they're looking at these blood samples both before exams and then during exams to see the difference in their T cell or their lymphocyte activity. Students were also given questionnaires to assess their psychological variables such as life events and loneliness that they were experiencing. Findings were that the blood taken before the exam contained more T cells compared with blood samples taken during the exam. So that means their bodies would have been more effective at fighting off illness before exams than they were during exams when they were experiencing very high levels of stress. Other research on stress and immunity shows that surgical wounds heal more slowly in stressed people. They gave dental students punch wounds. These are just very superficial wounds on the skin, but found that they healed 40% more slowly 3 days before a major exam compared with when the students were on summer vacation. Stress can also make us more vulnerable to colds. Researchers dropped cold viruses into people's noses. I know that sounds very strange. This is research, though. 47% living, quote, stress-filled lives got colds, whereas 27% living, quote, stress-free lives got colds. Disease progression. Over 33,000 participants were involved in this study of people with HIV, and they found that stress or negative emotions spread the transition from HIV to AIDS. Here's just another example of how researchers might study this. So in this case, participants are chewing gum so that saliva collection is easy. Researchers take saliva samples from participants at the beginning of this experiment to measure the cortisol levels or the level of stress hormone cortisol in their saliva. Participants then had to give a simulated job interview speech to a critical panel. Next, they had to compute difficult math problems out loud, which would stress me out. Then, afterwards, their cortisol levels were measured again from another saliva sample. And what we're finding now is that the cortisol level went up about 40% after the experience of the social stress during the course of the experiment. So we see beginning of the experiment, cortisol level, after the social stress that was imposed on them by the researchers, and we see a rise in the level of their cortisol or their stress hormone. And, obviously at the end, the research team would have to debrief the participants and explain the role that they played in the research.